All right, so 9 to the 1/2, or the square root of 9 is 3. And then what do I do with 6x and 1/2? Just like we did with 7x and 4, right? We multiply. So what's 6x times 1/2? 3x. So that'd be 3 to the 3x. Okay? So a little warm up there. And I'll give you the answers. Did we do 2 to... It's all up there, right? 2 to what? 10 even? 2, 4, 6, 8, 10. All right, so 2 was 16. No, I'm on the wrong spot. I'm back on 6-1. Sorry about that. 305, number 2. E to the second, 4, 9e to the third, 6, 64 over e to the 6x, 8, 2e to the 4x, 10 is e to the 2x plus 7. Any of those you'd like me to go over? Of those? Here we just added them. X plus x is 2x, 4 plus 3 is 7. Just adding the exponents. This one, since it's cube root, I would have, instead of, here we did square root 1/2, I would have done 1/3 there. So basically, the cube root of 8 is 2, and basically you're just dividing 12x by 3 is what you get. E to the 4x is all you're doing. You could have done that here too. 6x, square root of 9 is 3, and the 6x square root of that is just like dividing by 2. So 3x. I could have told you that yesterday, I guess. Colin?
What happened with E on 7?
On answer. 7?
Yeah.
It's still there.
No, in number 7.
Oh, 7, sorry. Oh, I forgot. It should still be there. Thank you for correcting me. Yeah, it should be 3e to the 3x. Sorry. We're good on those first 5? And then what did we do? We did 13 to 16. All right, so match the function with its graph. Explain your reasoning. Well, I would we just did it in our calculator, right? And try to match it, right? So 13 was D, and 14 was A, and 15 was B, and 16 was C. And, these two, are decay, 14 and 15, so it'd be A or B, and 13 and 16 are growth because our exponents are positive, so it's, you got a 50-50 chance, I guess. But you could look at the table of values in your calculator too if you needed help matching those up. All right, then we did those 4. It says determine whether the function is growth or decay, and then you're supposed to graph it again. We're just doing that in our calculator, but we have a negative exponent there, so that's decay. Positive exponent there, so that's growth. Negative exponent, decay. Positive exponent, growth. And again, just put those in your calculator, okay? And then here was the PERT problem, right? So investment accounts for a house and education earn annual interest compounded continuously. So remember, when it's compounded continuously, that's our equation that we learned yesterday, our formula. Okay, the balance A in dollars of the house account after T years can be modeled by this. The graph shows the balance of the education account over time. Which account has greater principal? Okay, so this started out at $4,856. This one started out at $3,224. So this one down here had the greater principal, right? Which account has a greater balance after 12 years? Okay, so this one I'm going to do times 12 and get that answer. And then here, I'm going to look where 12 is and find it right there. It's a little bit less than $8,000. So let's see how much that is. So 3224. E, remember, is e to a power is second natural log. And then 0.05 times 12. Close it up. And that's 58 something. So this one here was more after 12 years because it was almost 8,000. We okay with that one? Any questions? And then this one, tritium and sodium, 22 decay over time in a sample of tritium. The amount Y in milligrams remaining after T years is given by this formula. The graph shows the amount of sodium remaining over time. Which sample has greater initial amount? Well, this initial amount's 10, and this one looks like 15. So the sodium has a greater initial amount. Which sample has a greater amount remaining after 5 years? Okay, so here's 5 years, and we're right there. And that's less than 5. Let's see what that is. Use our calculator. So we're going to go, let's just clear all that out. 10 e to a power, second natural log, negative 0.0562. And what was it after 5 years? Times 5. That's 7.55. So 7.55 is bigger than that because that's less than 5, right? So there's more tritium after 5 years. Make sense? Not too bad, is it? Gave us a formula. Graphing, and we're just going to graph on our calculator, okay? And then simplifying those natural log base E stuff is normal stuff you've done in the past. It's just an E instead of an X, Y, or Z. That's all. Okay? No questions? Okay. Today, we're going to talk about logs, logarithms. All right? So you guys know that 2 squared is 4 and 2 cubed is 8. However, for what values of x does 2 to the x equal 6? So we're going to learn how to solve that type of equation here when we start talking about these logs. Mathematicians define this x value using a logarithm and write x equals log base 2 of 6. The definition of a logarithm can be generalized as follows. Let b and y be positive real numbers. B can't be 1 because b's our base. 1 to any power is 1. So it says the logarithm of y with base b is denoted by log base b of y. So log base b of y equals x if and only if b, the base, to the x power equals the number y. Right? So those two equations are equivalent. The one on the left is in logarithmic form, and the one on the right is exponential form. Okay? So what you're going to learn how to do today is write something in logarithmic form and rewrite it in exponential form, and also take exponential form and write it in logarithmic form. Right? That's what we're going to do. Okay. So we've got some examples here I wrote in this thing. So log base 2 of 4 equals 2. That's logarithmic form. I can write that same thing in exponential form. The base is 2. The exponent is 2 equals the number 4.
Your attention, please. Ninth graders, last names starting with A through M. Please go to the main gym now for spring pictures.
3 to the
Ninth
third
graders, last names starting with
equals
A through
27.
M.
That's exponential form.
Now for spring picture day.
Log form. Log base what? What's the base? 3. Of what number? 27 equals what exponent? 3. Logs are exponents, basically. Okay. Thanks, Ellie. Don't forget your phone. Oh, I should have did that in blue, sorry. Log base 4 of 16 equals 2. Who can give me the exponential form? Maddie?
2 to the 4 to the 2.
Right, this is the base. Remember, say log base b. So that's your base over here. Oops, I want to make it green. That's right. And that's the exponent equals the number. So we say log base 4 of 16 equals 2. Its exponential equivalent is 4 squared is equal to 16. Okay, you guys know all these answers, right? Okay. So let's do this. Log base 1/2 of 4 equals -2. What's the exponential? Anybody? Nobody, huh? What's the base of my log? 1/2. What's the exponent? Equals the number 4. Okay? So you should be able to do that. So here's another one. Berkeley. What's that in exponential form?
It would be 4 to the
Log base 2.
2 to the 4th power equals 16.
Right. So when we say this, log base 2 gives you what the base is of your exponent. 2. Logs equal exponents. So that's your exponent. 4 equals whatever number came after log. Serenity. Good. And anything to the 0 power is 1, right? That's correct. Log base 4 of 1 is 0. Whenever, no matter what the base is, if that number is 1, the answer is always going to be 0. Rosalie? No. Because if we don't put 0 there, we're thinking the exponent's 1. And 4 to the first is 4, right? So always put the 0. Ethan.
12 to the first. 12.
Good. We're getting the hang of it? Birthday girl. Good. Again, log base 1/4. That means it's 1/4 to the negative first power equals the number 4. Questions? think that's it for that slide. How about this one? Going the other way. Preston.
Log to the fifth,
Log base 5.
25.
Yes. Equals 2. All right. So this is our base. So that's log base 5 of 25 equals the exponent. Remember, logs equal the exponents. Right?
Okay, so log 10 to the 0.1 or of 0.1
Of 0.1, right? Equal.
equals negative 1.
Good. So that's our base. So log base 10 of the number equals the exponent negative 1. Ryan? Oh, it's on the other side. Good. Good. So if they flop sides on you, don't get confused. 8 is still the base. So log base 8 of our number equals our exponent. Okay. Right. I'm kind of in the way. Sorry. Should make that higher. Questions? We're getting the hang of it, right? Understanding those, going from one to the other makes this really easy, but you got to understand that. Any questions? This will help us solve some logarithms. Okay. Couple special logarithm values you should learn to recognize. So we talked about this. We had one already. Log base b, whatever number of 1 is always 0. So if the 1 is the number after the log, the answer is always 0. Okay. If the base and this number are the same, they basically cancel each other out. So the answer is 1. Okay.
Your attention, please. Ninth graders. Last
So,
name starting
again,
with
if you see a 1 on this side, it's always going to equal 0. And if these are the same, like log base 5 of 5 or log base 12 of 12, those basically cancel each other out. Okay? And then what it is actually is whatever exponent's up here. Well, there's no exponent, the exponent's 1. Like if that was a 2 there, then that'd be a 2. If that was a 10 up here, then that'd be a 10. But there was no exponent there. But those are pretty easy to recognize. I think that's it for that slide. Yeah. Okay, so this says evaluate with no calculators, okay? So here's what you do. Always write, when you have to evaluate with no calculator, always write equals x after it. And then rewrite it in exponential form. So what's this in exponential form now? What's the base? 4. What's the exponent? X. What's it equal? You guys can look at this and tell me the answer. What's x got to be? 2, right? 4 squared is 16, right? I know you guys are thinking 4 times 4, right? But that means the exponent's 2, right? Or if you want, you can think like this first if you want. So if these are both 4s, then these got to be equal, right? So x equals 2. Okay, so change it from log into exponential. So always write equals x after it. So then we rewrite it. What's the base? Thank you. What's the exponent? Equals 125. Well, 125 is 5 times 5 times 5. So what's my answer? 3. Again, no calculator is being used right now. Right equals x. So rewrite it in exponential. Base is 5. Exponent is x equals 1/5. Okay? Well, I don't want my 5 in the bottom. I want it in the top. So what happens to this exponent down here when it goes up to the top? Right? It becomes negative. So 1/5 and 5 to the negative 1 are the same thing. So what's x equal now? So these got to be equal then, right? Once you get the same base on each side, whatever the exponent's got to be equal. So when you get into the fraction stuff, you got some negative exponents you got to think about. All right, again, we're going to write equals x. All right, so this is 1/5 to the x power equals 125. All right, well, I want to get the same base for both of these. So what base should I use to get both of them the same? We've seen a lot of it already in our examples. What number? 5, thank you. So this is 5 to the negative 1 to the x power, and this is 5 to the third. What's negative 1 times x? Negative x. So I got the same base now, so I would just set my exponents equal. So my answer is negative 3, because it was negative x equals 3. All right. All the ones before so far were positive x's to start out. Questions? Okay. All right. So this says equal x. All right. So I'm going to rewrite it as 8 to the x equals 0.125. Well, I need to try to get that with the same base of 8. All right. Well, how do we say that number properly? Not 0.125. What do we say? 125 thousandths, right? That's the proper way to say that. Well, since it ends in a 25, we know what number goes into it. 5 or even 25, right? So let's do 25. It's bigger than 5. We want to reduce this thing. 25 goes into there 5 times. And 25, how many quarters in a, basically that's $10, right? $40, right? Got 4 and $1 and $10, right? So 4 times 10, 40. Well, how many times does 5 go into 5? How many times 5 go into 40? So this is 8 to the x equals 1/8. Well, how should I write 1/8? How do we do 1/5? 8 to the what? How do we get it to move up? We make it negative 1. So what's our answer? So that one took some work. But again, we didn't have to use a calculator. Right? We used the one we were given. We were born with, right? Okay, again, right equals x. That makes it all easier. All right, so that means 64 to the x power equals 8. Well, can I change 64 to a base of 8? 8 to what power? It's 64. 2, right? Remember, that's a 1. Well, what do I got to do with my exponents when there's one inside, outside? You multiply them, right? So now, since I've got this, I can say 2x equals 1, and then divide by 2. So what's my answer? 1/2. Okay? So far, so good? Making sense? Hopefully. All right, common log is a base 10 log. That's the one on your calculator. Right next to the 7. Says log, right? That's the common log, base 10. A lot of times they won't put a base next to it. If they don't, the base is 10. You don't see a little number, a little subscript like you've been seeing. The base is 10. And you'll see that. You won't see this. Natural log is the ln one. The base is e. You'll see this, you won't see that. Okay? And that's, you got that button in your calculator. So you can use those two. If you get a common log, you can just use the calculator. Right? So just hit in your calculator log of 8. Brett, what'd you get? 0.9? 3 decimal places. Thanks. Again, just put in your calculator. Hit log 8. Usually it gives you a parenthesis, right? I always say close it up. Log 8. I always say close it up. Right? 3 decimal places. ln 0.3. So do it quick. Hit the ln button. ln 0.3. Close it up. Negative 1.204 to the 3 decimal places, right? So if you have to do those, this is calculator work. Okay? All right. We talked about this already. What happens if these two numbers are the same? What do they do? They cancel. So whatever the exponent is up there, that's the answer. Okay? If you see something like this, that's kind of hard to see, but it's this. B to the log base B of x. Okay? If I have a base of B, let's say 5, and I have a log base 5, they basically cancel each other out. Whatever comes after is the answer. Those are inverses of each other. They undo each other. Okay? So this, it was kind of hard to see also. It's log base B of B to some power. Those just cancel. So whatever's there is the answer. So you'll get some problems that look like this. If there's no number there, what's the base? What did I just tell you? 10. So what's this 10 and that log do to each other? So what's the answer? 4. It's that easy. Okay, this isn't a 25, but I could write it as what? How could I write 25? 5 squared, right? And then what do I do with the 5 squared and the x? Oops, not LG, but LOG, right? The rule is to do that, right? So what do these two do to each other? Cancel, so what's the answer? 2x. Okay? Again, there's no number here, so what's the 10 and the log base 10 do? Cancel, so it's 18. This one again, I got to rewrite 16 as 4 squared. So this is log base 4 of 4 to the 2x, so those cancel. So it's 2x again. Okay? So you have a few of those as well. Questions? All right. Your practice is right there. So 20 to 22 even, don't use the calculator. Do like we did. 23 to 28 is this log and natural log. Hit the button and do it. And then 32 to 38 even is the last ones we did. Good job today.